Hi, in this video I'm going to discuss some problem types in section 1.5 that I didn't have a chance to go over in class. This first problem is number 6 on your homework. It wants us to find the point on the graph at which the tangent line is horizontal. So remember, horizontal just means we have a slope of 0 and the slope of the tangent line is the derivative. Okay, so our function is 2x squared minus 3x plus 3. So first I'm going to find the derivative. This will give me the slope of the tangent line at any point x. Using the regular rules we talked about in class, this is 4x minus 3. All I need to know is where this is 0, so I just want to solve 4x minus 3 equals 0. I get, okay, so I'm going to add 3 to both sides, and I'll get 4x equals 3. Then I divide both sides by 4, and I get x equals 3/4. What should happen is, if you graph this function on your calculator, you should see that it looks, I don't know exactly what it looks like, but it should look something like this. And right here should be x equals 3/4, because what a horizontal tangent line means is it's horizontal. So it's usually when the function switches directions, pretty much always. Okay, my next problem is going to be number 11 on the same homework. I'm talking about this problem because it has notation we didn't talk about in class. This just means the derivative. We did talk about that. And this means evaluated at x equals -2. That's what the line means. So we have y equals 1 over x cubed. I like to write as x to the -3. So dy dx is equal to -3x to the -4. So dy dx evaluated at x equals -2. That just means I plug in a -2 for this. So that's -3 over -2 to the 4th, which is -3 over 16. Okay, my last problem is section 1.5, number 12. It wants us to use the derivative to show whether the function is always increasing, always decreasing, or neither. So the key here is, I think we discussed this in the previous section, when your function is increasing, which this is, you have f prime is greater than 0. When your function is decreasing, like this, you have f prime is less than 0. So we just want to look at f prime and see if it's greater than or equal to 0 or less or whatever. So I'm just going to take the derivative. F prime of x is 3x squared plus 5. I don't have to use a lot of fancy math to figure this one out. X squared is always positive, right, because it's a square. Multiplying it by 3 doesn't make it negative, and adding 5 certainly doesn't make it negative. So f prime of x is greater than 0 for every x. And that tells me that f of x, the original function, is always increasing. That's it.